Welcome, this is the IM2 video lecture on understanding the quadratic function. The learning target here is for you to understand the characteristics of a parabola. The success criteria for today's lesson are twofold. One, you should be able to determine the characteristics of a parabola, and two, determine how the coefficient of A affects the parabola. We'll start this off with an exploration of the quadratic function in the prior units. A prior unit question would be solve x squared plus 2x equals to 3. Step 0 was to always to put it into standard form. That will include us subtracting 3 to both sides, getting us x squared plus 2x minus 3 equals to 0. Step 1 is to graph the related function, and we said that would be f of x equals to x squared plus 2x minus 3. Sometimes you might see it as y equals to that value. The difference is f of x, this is in function notation, right? And when you graph it in DESMOS, let's pull that up. You can enter it in here as f of x equal to x squared plus 2x minus 3. And it should look like that. Or you could enter it as y equals x squared plus 2x minus 3. Notice they overlap because it's the same thing. That's how it should look like. Okay? This is going to lead us to our core concept. This is going to be called a quadratic function. F of x is equal to ax squared plus bx plus c. The shape that it takes has a special name. The curve is called a parabola. There are certain things that you can get from a parabola. One, a parabola has a vertex. The vertex is the point where the curve turns directions. It's either the minimum or the maximum. Notice here it is going down, then here it goes back up. That's what I mean by it turns. So it's going to turn at that point. That point is called the vertex, and it is represented by x comma y. So it's -1 comma -4. So we would say here that the vertex is -1 comma -4. From the vertex, we can determine the line of symmetry, or the axis of symmetry. In this case, it's considered to be a line. It is the equation on which the line that divides the parabola into two equal parts. So if you cut this parabola straight down the vertex, notice that this left side is equal to the right hand side. That is line that splits it in half is called the line of symmetry. And notice how it goes down, straight down the vertex. And the x is equal to -1 because it goes straight down. Also, you need to understand the domain and the range. The domain is considered to be the x values. So the domain are all the possible x values you can plug into this function. Here, you can plug in anything. So you can write -infinity. X can be greater than -infinity, but less than infinity. So it expands all real numbers. It goes from -infinity all the way to positive infinity. If you would like to see this in interval notation, it looks like this. Parentheses -infinity, comma, infinity. Or you can see it like this in advanced mathematics, symbolizing all real numbers. You might see this symbol in pre-calc. The range are your y values. The range is defined as all the resulting y values that the function has. It's the output. And in this case, the output here is -4, is the smallest y value it can take, and it goes all the way up to positive infinity. So you could say y is less than infinity but greater than -4. In interval notation, you can see it like this. Bracket, -4, comma, infinity, open parentheses. Okay? Let's review the core concept here by finding the vertex, axis of symmetry, domain, and range for the following quadratic function. Try this out. To approach this, you would have to grab DESMOS and type in the function. So f of x is equal to x squared minus 8x plus 16. Notice here you have it graph. So it's transfer it over. And now you could find the parts. The vertex is right there, and it is 4, 0. The line of symmetry splits it down straight down, goes through the vertex. So x is equal to 4 for the line of symmetry. The domain would be all sets of all real numbers. In bracket notation, it looks like this. Or interval notation, it looks like that. And the range are all possible values for y greater than 0. And in bracket notation or interval notation, it looks like 0, to infinity. Oh, we can close it here at 0 because it touches 0. Let's explore the effect of A. We have this graph from before. And the question asks, what is the A for the quadratic function? Well, it is the value in front. It's the coefficient in front of the x. And it is the value of 1. So the question is this. Let A become negative. So it becomes negative x squared. So let's take a look. Our original was this. Now we want to f of x is now going to be negative. Okay. What happened? Well, you should see here that it essentially reflects. All right. So what happened to the graph? It flips. The graph reflected. It flipped across the x-axis. This leads us to our core concept of reflecting the parabola. This A term that we made negative flipped the parabola. So there are two things a parabola can do. It can open upwards or it can open downwards. So it opens upwards when that A value is positive, when positive A, right? So when you're positive, you smile. That's the way you want to think about that. And in that case, it has a minimum. A minimum's right here. And this is the minimum. And it refers to the lowest point. But when your A value is negative, it opens downwards. That's when you're sad. Okay, you're frowning. And that is when it has a maximum. And this is referred to the highest point. Now, I would like you to practice. Given these 4 problems, you have to tell me how it opens. Up, down. And the way you approach that is by looking at the A. Give that a try. All right, let's do the problem now. So the first one, you have to use DESMOS to help you out. G of x is equal to x squared plus 4x plus 9. And we saw that it opened upwards. The next one, g of x is equal to negative 1/2 x squared plus 1x minus 3 divided by 4. We saw that went down because notice the A here is negative. So that went down. The next one, g of x is equal to negative 2x squared. So that should be pointing down because of that negative 2 in front of the x squared. Yep, we were right. It was pointing down. Then lastly, we have the last one, which has a positive 3x squared. So that positive 3 in front should tell us it is opening upwards. And yep, that went positive upwards. Good job. From here, we're now going to see how the A changes a bit more. So we saw that the A here was equal to 1. So let's just graph that here. F of x is equal to x squared minus 8x plus 16. Okay, that's how it looks like. Now, we are going to half that function. How would the graph change? Okay, how would that graph change? Well, we're going to graph it. We'll 1/2 that function. Okay, we're going to see how that changed. Whoa, once we introduce that 1/2, notice it was from the red, then it went all the way to the blue. So it got what? Wider. Okay, you could say words like it got stretched, it got fat, it got wider. Okay, and if you say stretch, it's stretched horizontally. Okay. Now, let's see what happens when A is bigger than 1, like 4 times x squared. So now I'm going to have a 4 times the function. Whoa, notice, right? Our original was in red, right? And the next one is in green. Wow, it looks like it got smaller, right? So we would say here that the parabola shrinks. So that's what I mean by shrinks. Okay, or you could say it got skinnier. And in the process of getting skinnier, it got taller. So you can say that it shrinked and it got taller. So those are how A affects the parabola. Let's look at the core concept. Okay, these are your 3 cases. Given the standard form of the parabola, when A equals to 1, we would say that the parabola stays the same. Because when you multiply anything by 1, it remains the same. In green here, I show you that A is now greater than 1. And when I look at the A, I am only looking at the magnitude. That refers to just the number. When the number of A is greater than 1, the parabola gets narrow. Notice the green here is more narrower. Or when A is less than 1 but greater than 0, so the parabola is between 0 and 1, the A value, like a fraction, the parabola here gets wider, like the purple. The example I show you is 1/2. Here's the practice problem. The 4 problems that we have here, we just have to tell us if it was narrow or wide based on the original function of the original was f of x is equal to x squared. So we're going to compare that to x squared. Okay? Let's do that here. So our original was f of x equals to x squared. Right? That's the original. Okay? When we graph the first one, right here, your x squared plus 4x9, notice these here are the same shape. Right? Visually, if you can't tell, right here, you would say it stays the same because the A is equal to 1. the a here is equal to 1. The next one, we saw that it flipped, but if we just look at the shape, notice the blue here is slightly bigger, right? The parabola here got wider. So we would say that it got wider because the absolute value of the a is greater than 1. That's the reason. Next, what about the third one? When it's negative 2x squared. So when we compare it, notice the green here is slightly skinnier, right? It got narrower than the original black one. So we would say it got narrow. This is the reason why, because, oops, I wrote this one wrong, sorry. So for 2, because it was a fraction. Number 3, because it got narrower. That is when the absolute value of a is greater than 1. Right here, greater than 1. And for number 2, this was the fraction. Sorry about that. And 4, when we take a look, all right, the purple here is skinnier. It is more narrow. So we would say that it is narrow. And again, because the a here is 3, it is greater than 1. Okay, and that is how the a coefficient affects the parabola. The a affects the dilation of the parabola. There you go. These are your core concepts when it comes to understanding the quadratic function.